Recording has started.
So for first one here, excuse me, we need to get y by itself. Y has been multiplied by -2, and then 3x has been added to it. So to take it apart, the first thing we have to do is subtract the 3x. So the 3x will be gone there. We have -2y. On the other side, 4 minus 3x can't be combined. It's just going to be 4 minus 3x. Excuse me. So then to get rid of the -2 is multiplying the y, so we're going to get rid of it by dividing. When we multiply or divide, remember, we don't need the same name. So we can multiply or divide every digit on each side of the equation. So on the left side, the -2's just cancel out. We have y equals. On the right side, we have 4 divided by -2, which is -2. Then we also have the -3x divided by -2. Well, first, a negative divided by a negative is going to be a positive. 3 divided by 2 is just going to be 3 over 2. And then we'll put the x there. Excuse me, I don't know why I'm coughing so bad this morning again. Anyway, we start out then with the number by itself, the -2. That tells us that from the origin, we go down 2, and that point is where our line starts. From there, then, the number that multiplies x is our slope. Remember, that's a rise over a run. So that's saying that from that point, we rise 3. 1, 2, 3. And we run 2, and that gives us the second point on our line. And those are far enough apart, I can draw my line through them. For number 2, we'll start out by subtracting the 5x. So 5x is gone. We have just 3y on the left side. On the right side, we have 3 minus 5x, which is just going to stay as 3 minus 5x. On the left side, we have 3 times y. We have to get rid of that 3, so we're going to divide by 3. Remember, we have to divide each piece on the right side as well. So on the left side, the 3's divide out. We have y equals. On the right side, 3 divided by 3 is just 1. Negative 5x divided by 3. Well, negative divided by positive is a negative. 5 divided by 3, we're just going to write it as 5 over 3, and then put the x on it. So we've got the positive 1 there, which tells us from the origin, we go up 1. We start out there, that's our first point on our line. Now it's multiplying the x is a -5/3. Remember, the negative always goes with the rise. The run is always left to right. The run is always positive. So a -5/3, the negative means we goes down 5. 1, 2, 3, 4, 5. And then we run 1, 2, 3, giving us our second point. So there is our line. For 3 and 4, I'm going to do number 4 first, because with 4 I can do just this. I can just add plus 0x. And now it's really pretty much the same as the 2 above. The -3 says from the origin I go down 1, 2, 3. That's my first point on the line. The 0x is saying a slope of 0. I can write that as a 0 over 1, which means I rise nothing and run 1. That's a flat or horizontal line at y equals -3. For x equals 2, Well, if y equals -3 is a horizontal line, it makes sense that x equals 2 would be a vertical line, and of course that'll be at 2. So there's x equals 2. Now remember, we discussed this briefly yesterday. The slope of a flat line is 0. We saw it right here. If I pick 2 points on it, it rises nothing, but it runs whatever we want, however far apart the points are that we pick. 0 divided by a number is just 0. However, the slope of a vertical line is either undefined or doesn't exist. Using that same logic, if I take 2 points on that line, I can get whatever rise I want, but I get 0 run. So the bottom number would be 0 in our slope. We cannot have 0 in the bottom of the fraction because that would be dividing by 0. And when we divide by 0, bad things happen. Now you see the calculator just gives us a division by 0 error. A little story about dividing by 0. This is actually back in the early 1990s, so it's been a while. A Navy battleship, extremely large vessel, one of the highest levels of concentrations of technology in one place in the world. They had a new satellite navigational system, and they had been using it for a couple of years. And then what the navigational system did was use the satellite coordinate to locate where the ship was at that point. And then they entered a coordinate as to where they were going. And the computer system calculated the shortest path to get there. A lot of people think the shortest path is a straight line. It is not. If it were a flat world, yes. But since it's a globe, it's an ellipsoidal globe. It's elongated at the equator. The shortest path is usually a curve like that. If you look down from the top of the world, that shortest path looks like a straight line from that angle. Anyway, this system had been being used for almost a couple of years. It had never happened before, but it just happened to happen on this day. The coordinate to where it was going was exactly the same coordinate in one of the directions as where it was at. So when it subtracted the coordinates to do the calculation, it got a 0, and the system ended up dividing by 0. Well, it did exactly what my calculator did here when I divided by 0. It gave an error. The only problem is when those big computer systems give an error, if it's not programmed into them what to do, the computer system locks up. And on a vessel like that, it takes, depending on the computer system, 6, 8, sometimes 12 hours to shut it down and reboot it. So you had this billion-dollar battleship sitting in the middle of the ocean, dead in the water because the system had to be shut down to reboot. And it was just because I tried to divide by 0. Okay, so anyway, back on topic, back to graphing here. Today we're going to look at going in the other direction. If we're given information or given a graph, how do we find the slope, the y-intercept, the equation? Lines really only have 2 pieces of information about them. They have y-intercept, the slope. So if I have a line on my graph, like this, if I can find those 2 pieces of information, I can write the equation. Because the equation if I let m be the abbreviation for slope, and the letter b be the abbreviation for the y-intercept, the generic form, we call it the slope-intercept form of an equation, is y equals mx plus b. This is called graphing form, or slope-intercept form. Of an equation for this. The graphing form comes from, if this were a more advanced math course and we got into shortcuts for graphing parabolas and other different, more complicated curves, they would all have a form very similar to that, y equals mx plus b. Anyway, looking at this line here, first of all, the y-intercept is relatively easy to pick out. We find our y-axis, which is right there, and we see where this line crosses the y-axis. That's 1, 2, 3 units up from the origin. So that y-intercept is just a positive 3. To find the slope, we need to find two lattice points, or two coordinate points, if you will. And most lines on the graph intersect the axes. So it's often easiest to find those coordinate points where the lines intercept the axes, like this. Now I need to do a rise and a run. So I think I was having like an imaginary triangle here from one point to the other, going left to right. Well, we can see this is not a rise, this is a drop here of 3, so it's a minus 3, and a run of 1, 2, 3, 4. So a rise of negative 3, a run of 4, negative 3/4 is our slope. Now we can write the equation from that. Y equals slope times x, so it's negative 3/4 times x plus my y-intercept. My y-intercept's a positive 3, so it'll be plus 3. And that's the equation of that line. So for this one, again, we look at the y-axis here to see where we cross. And that is down 1, 2 spots. So my y-intercept, it's 2 units below the origin, so that makes it a negative 2. For the slope. So again, we need those two lattice points or coordinate points. One is right here on the y-axis, or at our y-intercept at negative 2 there. The other point I'll find here is on the x-axis, right there. To get from one to the other, we would rise 2, so that's up 2. And we'd run 1, 2, 3, 4, 5. So a run of 5. So that is the slope of 2 over 5. Giving us an equation. Y equals slope times x, so that's 2/5 times x. Plus the y-intercept. Well, the y-intercept is a negative 2, so we're going to do minus 2. So y equals 2/5 x minus 2 is the equation of that line. I want to do one more example here together, then I'll have you guys try one. So this one here for the y-intercept. That's where it crosses the y-axis. That is 1, 2, 3 units up from the origin. So that's a positive 3. For the slope, well, we have our lattice points, our grid points where it crosses the axes, but the axes no longer, have the rise and run anymore. They're off on the wrong side of the line. So we'll sketch it in over here. But I'm still going to use my axes to count, because going from here up to here is the same as this distance here, which is up 1, 2, 3. So that's a rise of 3. The same here. This run is the same as this distance down here. Remember, this is the rectangular system. The coordinates form rectangles. So down here I have a run of 1, 2, 3, 4, 5, 6. That's a run of 6. So my slope is a rise of 3 and a run of 6. Well, now that I have that fraction, I'm not going to leave it like that because it can be reduced. I would not reduce to a mixed number or anything like that. It would always stay as a fraction. But here, both the 3 and the 6 can be divided by 3. 3 divided by 3 is 1. 6 divided by 3 is 2, giving us that slope of 1/2. So now the equation is y equals slope times x plus y-intercept. Well, y equals 1/2 is my slope times x. Y-intercept's a positive 3, so it's a plus 3. So in your notes, I'm going to try to find the equation of this line for us. So our y-intercept from the origin, we go down 1, 2, 3, 4. There's our y-intercept at -4. For our slope, we have the 2 coordinate points on the axes here. Again, our triangle kind of goes on the wrong side, so we'll draw it down here. But this distance will be the same as this one, which we just saw was down 1, 2, 3, 4. So it's a -4. For our rise. For our run here, it'll be the same as this distance up here, which is 1, 2, 3, 4, 5, 6. So we have a slope of -4 over 6. Both 4 and 6 can be divided by 2, giving us a -2/3 as our slope. So our equation, y equals -2/3 times x, and the y-intercept of -4, so -4. One example I should do, just to avoid any confusion later. Would look like this. So here, y-intercept, 1, 2, 3, 4, 5. It's down 5 from the origin. That's a negative 5. For my slope, I'm going to go from here to here. I can use my axes. 1, 2, 3, 4, 5 rise. 1, 2, 3 run. So my slope is a 5 over 3. Now, if this were a regular fraction, we would reduce that to a mixed number of 1 and 2/3. But it is not a fraction, it's a slope. And a slope is a ratio. Because it's a ratio, it's always going to stay as an improper fraction. So this will be written as y equals 5/3 x, and then the minus 5 for the y-intercept. We don't always have two points, two intercepts on the axes to graph a line from. Let's say that we have that y-intercept here at 0, 8. But this line does not slope enough to get down to where it's on the hits the y-axis before it goes off the side of the graph. Let's say we do have a point over here at, well, we'll call that 10, 6. We draw in our rise and run here. Looking at the rise, the coordinate that describes that rise, because it's up and down, is the y-coordinate. This is a 6 down here. This is an 8 up here. That gives us a difference of 2. Actually, it's going down 2, so I'll put a negative 2 in front of it. For the run, the coordinate that describes the run, because the run goes horizontal, is the x-coordinates. This is 0 here, and this is 10. That's a difference of 10. So that's a run of 10. Slope of that line, we have a rise of negative 2, a run of 10. Now that is still reducible. Negative 2 can be divided by 2. 10 can be divided by 2, giving me a negative 1/5 as my slope. But more importantly is what we did with the coordinates to find those numbers, the negative 2 and the 10. Because slope is a rise over a run, and as we just saw, the rise can be found from the y-coordinates. So I'm going to label it like this, y2 minus y1. That's just saying you take one y-coordinate and subtract the other y-coordinate. The 2 and the 1 are just to make sure we keep them in the same order. So the difference in the y-coordinates is our rise. That's what we did here. The run is what we did here is the difference in our x-coordinates. x2 minus x1. So the formula gets written as m, remember, is our abbreviation for slope, y2 minus y1 over x2 minus x1. If I look at the coordinates I had up here, I had 0, 8 and 10, 6. If I label those points as point 1 and point 2, that part's important for these little the subscripts, the 2 and the 1 on the x and y. My slope, my rise, is y2 minus y1. Well, y2, I go to point 2, the y-coordinate, that's the 6. Then I have the minus. y1. Well, that means I go to 0.1, the y-coordinate, which is 8. Put in the 8. Then on the bottom for the run, I have x2, so I go to 0.2, the x-coordinate, which is 10, minus x1, I go to 0.1, the x-coordinate, which is 0. And then it's a matter of doing the order of operations with subtraction here. 6 minus 8 is a negative 2. 10 minus 0 is 10. Negative 2 over 10. Both divide by 2. Give us a negative 1 over 5, or negative 1/5 slope. So if I have that a set of points like 3, 5, and 6, 3. If I want to find the slope of the line through those 2 points, I label them 1 and 2. My formula, of course, my slope is y2 minus y1 over x2 minus x1. For y2, it's 0.2, the y-coordinate, which is 3, minus y1 is 0.1, the y-coordinate, which is 5. For the run then on bottom, I have x2, so I go to 0.2, the x-coordinate, which is 6, minus x1, so that's 0.1, the x-coordinate, which is 3. And then I subtract 3 minus 5 is a negative 2. 6 minus 3 is 3. So that is a negative 2/3 is my slope. Let's take points like 12, 1, and 4, 10. So again, I'll label them 0.1 and 0.2. My slope is y2 minus y1 over x2 minus x1. So y2, 0.2, y-coordinate is 10, minus y1, 0.1, y-coordinate is 1, over x2, 0.2, x-coordinate is 4, minus x1, 0.1, x-coordinate is 12. Now we subtract. 10 minus 1 is 9. 4 minus 12 is a negative 8. Now, 2 things here. That is an improper fraction, but we're going to leave it that way. We want to leave it as a ratio. It can't be reduced any other form, any other way. But we are going to move the negative. It's 9 over a negative 8. We'll put the negative out front to make it a negative 9/8 as our slope. All the examples I've given you so far, I've given you positive coordinates. So let's change that up a little bit. Let's do negative 3, 7, and 6, negative 5. So I'll label them 0.1 and 2. Slope, of course, is y2 minus y1 over x2 minus x1. So now y2, 0.2, the y-coordinate is a negative 5. Minus y1, 0.1, the y-coordinate is a 7. On bottom, x2, so that's 0.2, x-coordinate is a 6. Minus x1, so 0.1, x-coordinate is a negative 3. I'm going to put that in parentheses because we have the double negative there. Now we have negative 5 minus 7. Remember, that's negative 5 plus a negative 7, which will be a negative 12. 6 minus a negative 3, well, remember, that's just 6 plus a positive 3, or 9. Now, both 12 and 9 can be divided by 3. So we'll do that. 12 divided by 3 is 4. 9 divided by 3 is 3. We're not going to worry about the fact that that's an improper fraction, because remember, it's a ratio, not really a fraction. So we'll leave it as 4 over 3. And we do have to remember the negative out here. We'll put the negative out front. It's a negative 4/3. When we're dealing with our slopes, when we have a negative slope, we can actually put the negative anywhere. Negative 4/3 like this is equivalent to having a negative 4 over a positive 3. Because remember, a negative divided by a positive is still a negative, which is equivalent to doing a positive 4 over a negative 3. A positive divided by a negative is still a negative. It's just we prefer to put it like this with the negative out front, knowing that we're going to put the negative with the rise when we go to graph it. Okay, so in your notes, I want you to try 1 and negative 4/14. Find the slope of the line through those 2 points. So we'll label these points 1 and point 2. Our slope is y2, so point 2, the y coordinate, which is 14, minus y1, so point 1, the y coordinate, which is negative 1, over x2, which is the negative 4, minus x1, which is the 8. So 14 minus a negative 1, remember that becomes 14 plus a 1, so that's positive 15. Negative 4 minus 8, that becomes negative 4 plus a negative 8, which is a negative 12. Both 15 and 12 can be divided by 3. 15 divided by 3 is 5. Negative 12 divided by 3 is a negative 4. I'll put the negative out front. Right, that is a negative 5 over 4 is our slope. So if I give you that we have a line with a slope of 2/3 and a y-intercept of negative 4, we can write the equation of that line rather quickly, because it's y equals slope times x, and then plus the y-intercept. Well, the y-intercept here is a negative 4, so it's actually minus 4. But we're not always given that specific information. We might be given that the slope of the line is 3/4, and that the line goes through the point 8, 2. If I want to find the equation of this line now, I know that y equals slope times x. So I still have the slope of 3/4 times x plus the y-intercept. Well, I don't know the y-intercept, so I'm just going to put the letter b in there for right now. To figure out what that y-intercept, what b is, I have this point. This point tells me is that at that line, at some point on that line, x equals 8 when y equals 2. So I can put those values in for x and y in this equation. So y is 2 equals 3/4 times when x is 8 plus b. Now the only variable left in that equation is the letter b, the y-intercept. So I can solve for that y-intercept. First, I'm going to combine what I can on either side, which is going to be the 3/4 times 8, which is 6. And now I will subtract the 6 to get b by itself. 2 minus 6 is a -4 equals b. So what that is saying is my y-intercept equals a -4. So now I can go back and write my equation. Y equals slope times x. Well, the slope was given as 3/4 plus the y-intercept. Y-intercept's -4, so I put -4 there. So if I'm given that the slope is a -3/2, that my line goes through the point 6, 1. I know that my equation is y equals slope times x. That's going to be -3/2 times x plus my y-intercept. But I don't know what the y-intercept is, so I'm just going to put in plus b. But the point that the line goes through tells me that at some point x is 6 when y is 1. So I'll put 1 in for y and 6 in for x. So 1 equals -3/2 times 6 plus that b still, plus my y-intercept. Now, I combine what I can on either side. -3/2 times 6 is a -9. So 1 equals -9 plus b. And then this, now I solve for b. I've got the 9 that's been subtracted, so I'm going to add 9 to both sides to get 10 equals b. So again, that is telling us that the y-intercept is 10. So to write my equation, y equals slope times x, that's the -3/2 is given as my slope, times x, plus the y-intercept is a positive 10, so plus 10. In your notes, I want you to find the equation. If the slope is given as 1/4, and the line is given as going through the point 8, 5. Find the equation. So we're given the slope of 1/4. So y equals slope times x. So y equals 1/4 times x plus our y-intercept of b. We know that x equals 8 when y equals 5. So we put 5 in for y equals 1/4 times, we put 8 in for x. We combine the 1/4 times 8, which 1/4 times 8 is 2. So 5 equals 2 plus b. And we'll subtract 2 from both sides, giving us 3 equals b. So that's saying that the y-intercept is 3. So our equation is y equals slope times x, so 1/4 times x, plus our y-intercept, which is a positive 3, so plus 3. Well, the next step would be just to be told that a line goes through the 2 points 4, 7, and 8, 5. Now, I'm going to argue that this information is really the same as what we've been given in the last few problems. We just have to work a little bit harder to get what we want out of it. I'll label them points 1 and 2. And we're going to start by finding the slope. Remember, the slope is y2 minus y1, so y2 would be 5, minus y1 would be 7, over x2 minus x1, so x2 is the 8, minus x1 is the 4. So 5 minus 7 is a negative 2. 8 minus 4 is 4. That can be reduced because both 2 and 4 can be divided by 2. Negative 2 divided by 2 is a negative 1. 4 divided by 2 is 2. So negative 1/2. Their slope. Now, we know from that our equation takes the form y equals slope times x, so negative 1/2 times x plus b. Now, for the last few examples, we've used the point that was given to put into the equation to figure out what b is. But here we have 2 points. Which one do we use? And the answer is it does not matter. Let's try it with both ways. Let's use the 4, 7 here first. We use the 4, 7. 7 goes in for y. 4 goes in for x. Negative 1/2 times 4 is a negative 2. We add 2 to get that 9 equals b. If I use the 8, 5, well, that would be saying that y equals 5 equals negative 1/2 times x equals 8. Now, we combine negative 1/2 times 8 is a negative 4. And we add 4. We get 9 equals b. So we get the y-intercept is 9 no matter which point we use. And it should always work out that way, that you get the same value for the y-intercept no matter which point you use. So that means our equation here, y equals slope times x, so negative 1/2 x, plus the y-intercept was a positive 9. Oops, get back here. So it is a plus 9. So y equals negative 1/2 x plus 9. It is time for a break, so let's take 10 minutes here. We'll come back at 9:31 and we'll continue from there.
Like, I don't get along. No. Well, yeah, but no, I can't handle her. That's it. When I go there, I always hope to God she's with me. I hope that's her 4 days out. She's off work. I just tell her yes. Yeah. Like one of those parents that thinks her daughter's everything. Yes. So it's right. Like that's how it goes. It's just like Haven, she can just she's the image is on. Go out. She snuck out one night. We were drinking at home when I went to. She like snuck out, and Jeff and Molly just woke me up and was like, "Oh my God, Haven's missing." And I like, yeah, she snuck out. Like I'm guaranteed she's at another party somewhere. And they're like, "No, she's not." I'm like, "Yeah." So I text her. I'm like, "Dude, what?" And I want to go to bed. So I'm at Chrissy's. Sneaks out concert. And they're like, "Oh no, I'm gonna kick her ass," and she's bed. She gets home and they're like, "You can go to bed. What do you want for breakfast?" Like, yeah, exactly. They do it all the time. They know she's like the worst kid. Like, Haven and Tristan's mom are the same. So irritating. to his parents, she's everything. It just seems like the worst. They hate her child. They're $14,000 loan. She decided she didn't want to work at the farm. She was up and quit one day just left.
Oh my God.
So Lori was making her payment, check payment, for graduation.
You want to pay my check?
That's what Tristan said. He said, "You want to pay my check off for when I graduated?
That's it.
You can pay that $30,000 loan." They took their whole stimulus check and put it on her. It's gas money, literally run around the party. When she was in school, they gave her like $50 a week for gas. They live way out in the middle of nowhere, so like to get to school. Just went to a different school, so I went to. They didn't give them a dime for gas. Which I mean, I get a parent could help with gas money when they go to high school.
Yeah.
So Haven got a lot, just never got anything. So he live working with Phillips. He drive from Hawkins to Ladysmith for school, which is like 45 minutes. Then from Ladysmith to Phillips to go work, which was an hour drive. Parents were like, yeah, we don't care. I don't even know how he still works. I like his dad a lot, but I can handle Jim. If it was up to me, Tristan should just.
Yes, yeah.
I can't afford one.
Get a rip job.
Yeah, after school.
Why not?
He doesn't want out. I'm so good for his parents. Why are you not coming back?
Give them like a fake home.
I like where they live a lot. I could just burn that house down and build my own. Can't happen until they die. Like, one day, next lesson. I'm living out. I can't get over it.
Well, since everybody's back in, we just will get rolling again here. So we can write equations. We saw this example here from just knowing any 2 points that are on the line. Let's do another couple of examples and we'll have you try some. We might have -5, 2, and 10. Let's do 10, 8. So to find the equation of that line, we start out by finding the slope. So if I call them points 1 and point 2 again, y2 will be the 8, minus y1 will be the 2, over x2 will be 10, minus x1 will be a -5. Well, 8 minus 2 will be 6. 10 minus a -5 is 10 plus 5 will be 15. Well, both 6 and 15 can be reduced by 3. 6 divided by 3 is 2, and 15 divided by 3 is 5. So we have a slope there of 2/5. So my equation takes the form y equals slope times x, so 2/5 times x plus b, my y-intercept. Now we said it doesn't matter which point we use, so I'm going to use the 10, 8 because both coordinates are positive there. I don't have to work with negatives. So that's saying x is 10 when y is 8, so I put 8 in for y equals 2/5 times, I'll put 10 in for x. Now I'm going to combine what I can. 2/5 times 10 is 4. So 8 equals 4 plus b. Now I can solve for b by subtracting 4. 8 minus 4 is 4 equals b. So that's saying the y-intercept equals 4. So my equation, y equals, my slope was 2/5, so slope times x, 2/5 times x, plus my y-intercept of 4. I'm going to have you try one in your notes. It's going to be 4, 7, -2, -2. See what you come up with there for an equation for that line. So first we need to find our slope. We'll call them point 1 and point 2 again. Slope is y2, so that's the -2, minus y1, which is 7, over x2, which is also -2, minus x1, which is 4. -2 minus a -7 is a -9. -2 minus 4 is -6. So both 9 and 6 can be divided by 3. -9 divided by 3 is -3. -6 divided by 3 is a -2. Now a negative over a negative makes a positive, so that's just a positive 3/2 slope. So we know our equation takes the form y equals slope times x. So y equals 3/2 times x plus our y-intercept. I'm going to use the 4, 7 because both of those points are positive. So the 7 goes in for y equals 3/2 times the 4 goes in for x. And we'll combine. 3/2 times 4 is 6. So 7 equals 6 plus b. We subtract 6, solve for b, you get 1 equals b. So that's saying the y-intercept equals 1. So the equation we're looking for here, y equals slope, which is 3 over 2 times x, plus the y-intercept of 1. So y equals 3 over 2 plus 1. Well, that is not the only form of an equation we can have. There's something called point-slope form of an equation. Point-slope form of equation is actually very useful in machining if you're going from one point to another, or if you have information like what we were just given, where we have a slope and a point. Point-slope form of an equation is our y-coordinate, or actually, sorry, not our y-coordinate, our y value minus the y-coordinate equals the slope times our x value minus an x-coordinate, where, of course, x1, y1 is a point that is on that line. So if I give you that we have a line that has a slope of 2/3, and through the point 6,1, the point slope form of that line is simply y minus y1 is the y coordinate of the point. That's going to be the 1 here, so that'll be y minus 1 equals slope, which is given as 2/3, times, in parentheses, x minus x1 is the x coordinate of that point, the 6. So that is our point slope form of the equation. Now, this is equivalent to what we would get if we did slope-intercept form. Let's do that slope-intercept equation over here. We would have done y equals slope times x plus b. We would have put in the point for x and y, so 1 is the y, 6 is the x. 2/3 times 6 is 4. Now we would have subtracted the 4. Get -3 equals b. So the y-intercept is -3, so that would have given us the equation y equals slope of 2/3 times x minus 3. That does not look much like what we have here, so let's do some work to turn this to make it look like that. First step would be to distribute the 2/3. So on the left, we just got y minus 1. Nothing we can do with that. 2/3 times x is 2/3 x. And 2/3 times -6 is a -4. All that's left to do to make this y equals is to get rid of the -1 here, so we're going to add 1. Remember, when we add or subtract, we can only combine with things that have the same name, which means we can only add or subtract to one piece on each side of the equation. So here on the left side, we add to cancel out the -1, leaving us with just y. On the right side, we have the 2/3 x. -4 plus 1 is -3. So you can see it is the same equation. It's just because of the information given, it was easier to find this form. So if I give you that a line has a slope of -1/2 and is through the point 8, 3. Our point slope form of the equation will simply be y minus, well, the y coordinate of the point is 3. So y minus 3 equals our slope, negative 1/2, times parentheses x minus, well, the x coordinate will be 8. X minus 8. Maybe try one in your notes. Tell you that our equation has a slope of 3/5 and goes through the point 5, 1. Find the equation, the point slope form of that equation. So here, we start out with y minus the y coordinate, which is 1, equals our slope of 3/5 times, in parentheses, x minus the x coordinate, which is the 5. And there's our point slope equation. What if we are told that our line goes through 2 points like we were before? Let's say it's going to be 3, 5, and 9, 1. And I want to find the point slope form of that equation. Well, our first step is going to be to find the slope. M equals, if I call them 0.1 and 0.2 again, y1 will be the 1 minus y2 will be the 5 over x2 will be the 9 minus x1 will be a 3. 1 minus 5 is a negative 4. 9 minus 3 is 6. And I'm going to just trust that you guys can reduce that to a negative 2/3. Now the question is, which point do I use to make my point slope equation? And the answer is it doesn't matter. If I use the 3, 5, I'm going to get the equation y minus the y coordinate would be 5 equals, my slope is negative 2/3 times x minus my x coordinate would be 3. I get that equation. If I used the 9, 1, I would have had y minus 1 would be the y coordinate equals negative 2/3 times x minus 9 would be the x coordinate. Those do not look like the same equation, but they are. Over here, let's distribute the negative 2/3. So y minus 5 equals negative 2/3 x. Negative 2/3 times a negative 3 is a positive 2. If I add 5 to both sides, I get y equals negative 2/3 x plus 7. So that would be the slope-intercept form of that equation. Over here, let's do the same thing. We're going to distribute that 2/3, negative 2/3. So negative 2/3 times x is a negative 2/3 x. Negative 2/3 times a negative 9 is a positive 6. And we add 1 to both sides to get y by itself. Y equals negative 2/3 x plus 7. So it is the same equation here as that. They just look very different because of the different point. So when we do point-slope forms of equations, the equation you get is going to depend on which point you pick to use. Sometimes it's handy to graph an equation in that point-slope form. If I give you that form of an equation and ask you to graph it, first thing I need to find is that point. Remember, the point is going to be the value that's subtracted from x is going to be the x-coordinate, so that's going to be 5. And the value subtracted from y is going to be the y-coordinate, so that'll be 2. So this is saying that this equation, this line, starts at the point 5, 2. So rather than being a y-intercept, rather than being on the y-axis, it's off in space on its own there. And the slope is 1/2. So from that point, we rise 1 and run 2 to get a second point on the line. There's our line. What if we have an equation like this? Now we look at this one, we got to be very careful. Our point, the x-coordinate is what's subtracted from x, that's the 4. Remember, the y-coordinate is what's subtracted from y. Well, this is y plus 3. So technically, that would have to be written as y minus a negative 3. So the y-coordinate here is a negative 3. So we go to 1, 2, 3, 4, down 1, 2, 3. That's our starting point right there, 4, negative 3. And our slope of 2/3 goes off of that. We go up 1, 2, and we run 1, 2, 3 to get a second point on that line. There's our line. The point slope form is also handy because sometimes the y-intercept is either unclear or it's an ugly fraction. So we might have a line like this. Where we know the line goes through the point 2,5 and it has a slope of 2/3. The y-intercept here is going to be between lattice points. It's going to be a fraction or a decimal. So in this case, it's much neater, cleaner to write the equation in that point slope form. So we have y minus the y-coordinate of 5 equals our slope of 2/3 times x minus my x-coordinate of 2. And there is the point slope form of that equation. The good news. For homework, I'm not going to give you anything new today. I'm just going to have you finish up those pages from yesterday. There is a quiz out there that I posted that'll be due Monday. What is Monday? November 16th at noon. So give me a little bit of a chance to catch up here. I know I've given you a lot of homework pages the last couple days. So finish up that homework, work on that quiz. We have about 27, 28 minutes left here. Didn't give you any work time in the first hour. So if you'd like to get started on that quiz, you may. I will be here on the network for a while for you to answer any questions.